Sigma. It is not about the symbol we do use in mathematics and science. It is about a signature language. If you are in cybersecurity, especially in the blue team side, like the security analyst or a detection engineer, then you might have heard this term. And it is nothing but an open source signature language that is compatible with most of the popular SIEM solutions out there. For example, if you are working as a security analyst, you are getting multiple alerts on various security events. Have you ever thought how these alerts are getting triggered and on what basis the detection is happening? And if you start thinking about this, then in this video, I'm going to give my answer for that. And TryHackMe also launched an excellent room to explain the Sigma, how you can write the detection rules by using the Sigma. So I'm going to walk through that room, and also we are going to write few Sigma rules to spot specific event that is present in the log file. And if you are talking about the Sigma, then the Sigma is mostly used to find the specific log pattern, which is very handy. You can learn this. It is worth learning Sigma so that you'll be able to write Sigma to detect any threat activity, and you can convert it to the specific SIEM that you are using. A few days back, I made a video about tactical detection. There I explained about this Sigma briefly in short, and also we have seen some tripwire setting up technique, like we have set a tripwire for a specific sensitive file, and we have also triggered the tripwire and seen what exactly happened. And today it's completely about Sigma, and without further ado, let me begin. Now we are in the recent TryHackMe room Sigma, and I have connected to TryHackMe's network. You can confirm it with the IP address that I have given, and also I have started the TryHackMe's machine. By using this machine, we are going to do certain Sigma rule creation activities, and we are going to detect certain patterns, and we'll be seeing it later in this video. Well, look at this tagline here: provide understanding to Sigma, a generic signature format for SIEM systems. So it says it's a generic signature, which means it can be built and it can be converted into various SIEM signatures. It gives that compatibility. That's why it has its own importance, and it is widely used by the security researchers. Well, let's move on to the first section, introduction. Detection engineering is an important role and task for security analyst, and some companies might be giving the detection engineering role to the security analyst, and some companies might be having separate department for detection engineering, and it involves developing processes that will guide you as an analyst to identify threats before they cause any harm to an environment through the use of rules. Well, these Sigma rules are going to detect the specific event. It can be harmful, it can be malicious or suspicious or some informational, whatever. You are going to define that based on your wish. You are going to build the Sigma rule, so it gives some flexibility to you in terms of detection. Well, this room will introduce you to Sigma, an open source generic signature language used to write detection rules applicable across different SIEM backends. So it can be written and it can be converted into various SIEM queries. Well, let's see what we are going to get from this room. It gives some introduction about the Sigma, and also we are going to learn the Sigma rule syntax and the conversion process. So we need to know how to convert from the Sigma rule to various SIEM queries, right? So we are going to learn that conversion process and navigate through writing rules for various detection on Windows event logs. And all the rules that we are going to write, we are going to exercise, we are going to practice in this room, or to find specific event on Windows system. And the last one, we are going to write a couple of Sigma rules to detect the real-time scenarios. Well, TryHackMe gave certain prerequisites before taking this room, and look at this. They gave they recommended certain rooms, and I haven't finished these rooms because I have some idea about the detection engineering and the security operations and the role of security analyst. So that's why I skipped these prerequisites. If you have some exposure to the forementioned technologies, then you can feel free to take this exercise straightly. Well, this is just a theory. So we have completed the intro part. Moving to the next one, the Sigma definition. Through log monitoring and analysis, SOC analysts are tasked with collecting, analyzing, and extracting as much usable information from logs and using it to build detection queries and searches for their environments. However, on most occasions, it becomes challenging to standardize investigations and have the ability to share them with other analysts for detection enrichment. Sharing the indicators of compromise and signatures may not be enough, as log events are often left unattended. Here is where Sigma seeks to bridge the gap. Well, they're trying to explain the importance of Sigma here in this para. Sigma obviously used to detect certain log patterns, right? Certain patterns from the log file. So it has its own importance. So that's what they're trying to say. Since it is a generic language, you can write your own Sigma rule and you can share it with others. So they'll be able to convert that Sigma to their respective SIEM query format. So that is the flexibility of Sigma. Okay, now Sigma is an open source generic signature language developed by these two, Florian Roth and Thomas Padsky, to describe log events in a structured format. This allows for quick sharing of detection methods by security analysts. And you can see when I am hovering my cursor on this, I can see the link at the left bottom. It is actually redirecting me to the GitHub Sigma page. So from this repository, you will be able to get the Sigma package and you'll be able to start writing the Sigma and start the conversion process. Well, and this allows quick sharing of detection methods by security analysts. It is mentioned that Sigma is for log files, as SNOT is for network traffic, and IARA is for files. So here is the short and sweet explanation for Sigma and its importance. Like Sigma is for log files, like SNOT is for network traffic, and YARA is for files. We do use YARA rules to detect the certain file patterns, and we use SNOT in order to detect the specific suspicious traffic or specific network traffic. SNOT is an IPS IDS solution. It's an open source. So like this, we are going to use Sigma to detect the specific events from the log files. Well, Sigma makes it easy to perform content matching based on collected logs to raise threat alerts for analysts to investigate. Log files are usually collected and stored in databases or SIEM solutions for further analysis. All right. Now, look at the use case here. Sigma was developed to satisfy the following uses, and here they gave the reason behind its development: to make detection methods and signatures shareable alongside IOCs and YARA rules. So this is what I have mentioned so far. And to write SIEM searches that avoid vendor lock-in. As I said, it's a generic format. You can write it and you can do the conversion later based on your SIEM solution. And to share signatures with threat intelligence communities. It can be shared with anyone. You can distribute to others. To write custom detection rules for malicious behavior based on specific conditions. Well, these are the importance of the Sigma, and these are the reasons behind the Sigma's development. And let's see the Sigma development process. As a SOC analyst, the process of using Sigma to write up your detection rules will involve understanding the elements mentioned below. Well, you have to learn, you have to know, the below stuffs in order to write the detection rules using Sigma. Let's see what are those. The first thing, the rule format, the Sigma rule syntax. Generic structured log description written in YAML. Actually, the Sigma rule is nothing but an YAML rule. YAML is nothing but a data serialization language which can be used by various programming languages, and it is human readable, user friendly, and it can be written easily. If you see any popular software, the configuration files would be either in JSON or in YAML. So It is widely used serialization language, so we are using it in Sigma. And the next one is the Sigma converter, a set of Python scripts that will process the rules on the backend and perform custom field matching based on specified SIEM query language. And we do have a separate Python package to convert the SIEM rule to various SIEM queries. All right. And the next one is the machine query, resulting search query to filter out alerts during investigation. The query will be based on the specified SIEM. So this is the query we are going to generate. So this is the result of the Sigma rule conversion. All right. Now this link again redirects to the GitHub repository of Sigma, and it provides information about the project public rules, because if you see this specific GitHub repository, you can see the available public rules, and they have separated every rule based on the operating system. And you can see for Sysmon they gave a couple of rules, Windows Sysmon. So you can directly use this Sigma rules and you can convert it and you can use it in your infra. Well, scrolling down again, we have done this theory part. Now we have learned about, a few theory stuffs about Sigma. Now moving to the next one, Sigma rule syntax, and you can see this symbol. It is actually giving some task files to download. Well, I have downloaded these task files. So this is the downloaded task file. It simply gives the skeleton of a general Sigma rule, and it will be containing these parameters like title, rule ID, status, description, author, date, modified, time and date. So it gives the metadata. And look at this, the log source, from which device, from which operating system, from which solution we are getting the logs. So those details can be mentioned here. The detection part is a crucial one. So this is where we are going to mention the pattern that we are going to match with the log file, and it will be containing the patterns under the selection. And here in the condition, we are going to mention the conditional statement, and we are going to refer this the portion under the detection here in this condition. And the rest of the stuffs are certain metadata like false positives, level, the severity level of the rule, and the tags where we will be able to add the MITRE TTPs. And this is the skeleton of the Sigma rule, and it can be used when you are writing the rule for the first time. The comment always added following the hash sign. So this is how you have to mention the comment in the YAML. And look at this, I'm just selecting all the texts here, and you can see the indentation. Indentation is not given by using the tab. You have to use spacebar to give the indentation, and you can see the dots here actually denotes the one character space. So I pressed spacebar and I gave the character space. So that's what denoted here. So that is very important in YAML. So these are the prerequisites, and also it is case sensitive. Now let's read through this Sigma rule syntax portion. As indicated in the previous task, Sigma rules are written in YAML, AINT markup language, a data serialization language that is human readable and useful for managing data. It is often used as format for configuration files, but it is object serialization abilities makes its substitute for languages like JSON. Well, they are trying to say the YAML is preferred over the JSON. All right. And you can see the common factors to note about the YAML files. So these are the conditions. When you are writing this Sigma rule, you need to keep these things in your mind to avoid any syntax error. YAML is case sensitive, so you should use small letters. If you use small letters, you should use caps, then you can use caps. So you should follow the case rules. All right. And the next one, file should have .yaml extension. So once you have created the rule, you should be mentioning these rules mentioning those rules with this extension. And spaces are used for indentation and not the tabs. And that's, just now I have mentioned it. You need to use spacebar to give the space, not the tab. And comments are attributed using the hash character, and that also I have mentioned. And the next portion I haven't mentioned before, but I'll try to explain this while I'm writing the rule. Well, look at this one. Key value pairs are denoted using the colon character, and you will be using colon to separate the key and value. And array array elements are denoted using the dash. When you want to mention multiple values under one field, then you'll be using the hyphen character. So that is to denote the array. So this is the syntax that you need to follow when you are writing the sigma rule. Well, moving to the next one, sigma syntax. So look at the image. So the image will be giving you some idea about the sigma rule syntax, and you can see the title. The parameters highlighted in the gray are the mandatory parameters. It must be kept in every sigma rule, and the title, log source, detection, and condition. These four are very important, and you can see the rest of the stuffs. Rest of the parameters are optional. It can be used or it can be ignored. And following the understanding of using YAML for sigma rules, the syntax defines various mandatory and optional fields that go into every rule. This can be highlighted using the image. And let's use an example of WMI event subscription rule. And here they gave a reference to a rule. To define different syntax elements, download the attached task file and open it in a text editor to go through the rule syntax and rule writing sections. So this is the file they are talking about. So here they gave the skeleton, the template to write the sigma rule, and that's what they are asking us to refer to. All right, they gave one link, right? So let's open this one and see what is kept here. And look at this. So this one is the sigma rule to spot specific events. So they have mentioned, so look at this one. This is the very important. So this is where we are going to define the log pattern that we are going to match. And under detection, they have mentioned the selection and also the event ID. So the event ID is the search identifier. So that is what it called as search identifier. And you can see the values here. So which is actually given after the dash, after the hyphen, because it forms an array. You can see here under the value event ID there are under the search identifier event ID you can see three values, 19, 20, 21. So any one of these event IDs matched, then it will be triggering the alert, then the rule will be triggered. So that is the case here. And let's move to the next one. Title names the rule based on what it's supposed to detect. It should be short and clear. That's very important. And ID, a globally unique identifier mainly used by developers of Sigma to maintain the order of identification rules submitted to the public repository found in the UUID format. Well, you can see this one here in the comment section. The unique ID that we can generate by using this website. So let's get into this website and generate a unique identifier. You can see this identifier now, and I am refreshing this page. It will be, it will change. And if I generate the unique identifier here by clicking the generate button, you can see the unique identifier generated. When I click it for the next time, it changes. Watch it now. The first part changes. So this is the unique identifier. You can simply generate one unique ID and you can put it in the rule that you are writing. So this unique ID is used to differentiate, used to give an identification to a specific Sigma rule. So that is the main use of it. Well, the next one, you may also add references related to the rule ID and related attributes, making it easier to form relationship between directions. Apart from the ID, you can also mention some references. So if you are inspired, if you inspired to make the rule from some blogs or some videos, then you can mention those links in the references. All right. And these relations, they have mentioned some relations, the relationship between the detections. And these relations would fall under the following types: derived, obsolete, merged, renamed, and similar. And you can see the respective definition for this. The derived, this will describe that the rule has sprung from another rule which may still be active. Well, if you are referring another Sigma rule in that rule, then you can mention this derived option. If it is obsolete, this is indicate that the listed rule is no longer being used, then you can classify it obsolete. Merged, here is the definition. Renamed, This indicates the rule was previously identified under different ID but now changed due to changes in naming schemes or avoiding collisions. If you are writing your own rule for the same scenario, you can use this one. And similar, this attribute points to corresponding rules, such as indicating the same detection content applied to different log sources. All right. Now the next one, status. If you see this one, stage of your rule testing, and this is another important parameter, another section, and describes the stage in which the rule maturity is at while in use. There are 5 declared statuses that you can use. Well, stable, test, experimental, deprecated, unsupported. You can choose any of these in the status, and look at the definition. If you are using stable, then it states that the rule is being used in the production environments or in dashboard. The rule is live. If it is test, then the rule is being tested. It is in the trial period. That's what it denotes. If it is experimental, then you are simply denoting that the rule is generic and it is being tested. It can be modified or it cannot be modified later. But if it is experimental, the rule is being experimented. That's what it means. And deprecated. The rule has been replaced and would no longer yield accurate result. In such scenarios, you can mention it as deprecated. Unsupported, the rule is not usable in its current state. That's the meaning. Well, the description. Actually, I'm not going to read through this because description, it depends on you. You can mention whatever you think. You can give the definition that you cannot mention in the title here in the description. And the next one, log source, which is vital. And look at this. Describes the log data to be used for detection. It consists of other optional attributes. Product. Well, under the log source, you can mention the separate field called product, and you can mention the value as any products like Windows, Linux. If it is a Windows operating system, it would be Windows. If it is Linux, it would be Linux. If it is a web server like Apache, then you can mention like Apache. So it depends on you. So that's what they gave here. And the category. The category is the subset of this product. Like if it is Windows, then it's an endpoint, right? Like that. It can be a firewall, it can be a web, it can be antivirus, or it can be proxy, whatever. So you can mention that category under this category field. And the next one is service. Apart from this product and category, you can use this service and definition. If it is service, then it's a subset of this product and category. For example, SSHD on Linux. If you are writing the rule to detect the SSH events, then you can mention the service as SSH daemon, SSHD. So that's what it's all about. And definition describes the log source and applied configurations. All right. So this is what the section of log source. And moving to the next one, detection. And it is very, very important. So this is where we are going to write the detection logic. A required field in the detection rule describes the parameters of malicious activity we need an alert for. The parameters are divided into 2 main parts. So look at this. Remember this one. It has 2 main parts. This specific detection section, the search identifier and conditional expression. Search identifier means the fields and values that the detection rule should be searching for. And here is the part. So this is what the search identifier. And you can see the search identifier, it has its field, and whatever the content present after this colon, it is considered as value. So look at this one, this specific structure, field colon value. So this is what the structure called maps. And in YAML, there are 2 formats we are going to use. Maps and lists. So this one is map. Selection is the field, and the things after this colon, all the things are values. So it has a map, and also it has nested list. You can see the value here. It has the search identifier, the field, and you can see the value here. It is actually separated by hyphen, which means it's a list. So there is a list nested inside the value of maps. So this is very, very important. This is an important structural stuff. All right, now let's see this. A required field in the detection rule describes the parameter on the malicious activity we need an alert for. The parameters are divided into two main parts: search identifier, the fields and values that detection should be searching for, and the conditional expression. So this part is the conditional expression, which sets action to be taken on the detection, such as selection or filtering. Here they mentioned selection, which means the event ID that matches any of these three, it will be alerted. So they have simply mentioned that matching parameter, and they called that here in the condition. So that's what this conditional expression part is all about. And this rule has a detection modifier that looks for logs with one of the Windows event IDs mentioned here, and that's the purpose of this rule. Well, moving to the next one, false positives. You are writing a sigma rule, but if there is any false positive scenario, like any legit scenario in that the rule might be triggered, then you can mention that such scenarios in the false positives. And the level, so it denotes the severity level. It can be from informational to critical, informational, low, medium, high, critical. So that's what you can mention here. And the last and final part is tags. So that is the last parameter given here in this skeleton. Many other parameters can be used, but in this skeleton, tag is given at the end. So tags is something where you can mention the CVE IDs. If you are writing sigma rule to spot a specific vulnerability, you can mention the CVE ID, or if you are writing it to spot a specific threat activity, then you can use the MyTrade TTP IDs and the method names. So that is what you can mention in these tags. So all the parameters we have seen so far, only few are very important, like titles, log source, detection, selection, and these parts are very, very important in Sigma. And you can see the highlighted stuffs are very important. Well, let's move on to the next one, search identifiers and conditional expressions. Actually, these two parts we are going to use under the detection part of the Sigma rule, which is a vital one. This is where we are going to mention the pattern that we are going to match and also the conditional expressions. And well, let's understand this, because if you understand these two stuffs in Sigma, then most of the Sigma rules are done. Then the rest of the things are like metadata and the remaining title, those kind of stuffs. Well, let's get into this. As mentioned earlier, the detection section of the rule describes what you intended to search for within the log data and how the selection and filters are to be evaluated. The definition of the search identifiers can comprise two data structures, list and map, which dictate the order in which the detection would be processed. Well, there are two data structures they are using in the search identifiers. The search identifier portion is nothing but the portion above condition. In the detection, under the detection, the portion above condition is called the search identifier. And you can see this one, the specific part. I'll try to explain what it contains. What is the structure here? And you can see this column. We have already learned this. Maps are separated by colons. I think we are going to learn it here in the next para. When the identifier are provided using list, they will be processed using strings like with the logical OR operation. Mainly, this will be listed using the hyphens. So let me explain the list first. So look at this one. The hyphen we have mentioned here. Actually, it denotes the OR operation. And the next one, for example, the below we can look at the we can look at the extract of the netcat PowerShell version rule. Now we are referring the netcat PowerShell version rule. So if you see this rule here in the selection stuff in this search identifier, you can see the hyphens mentioned here. This PowerCat and PowerCat.ps1 mentioned after the hyphen symbol. The hyphen denotes the OR operation. And that's what they have given here. This specific code snippet taken and given here. Well, and I'll try to explain this. On the other hand, maps comprise key and value pairs. So it has key and value. In Python, it is like a dictionary where the key matches up to a field in the log data, while the value presented is a string or numerical value to be searched for within the log. Maps follow logical AND operation. So maps follows AND operation, and list follows the OR operation. So I'll explain it, and look at this one. Here we have both list and map. Look at this one. It has the colon, and here it has a colon. Here is the colon. Actually, the colon actually separates both field and values. So it's a map. And look at the hyphen here. It's a list. If it's a list, then it's the OR operation. Now what we are trying to say here, the image that ends with either RM or shred. So it matches any of this, then it will be triggered. Like this, the command line. Under the command line, there are two values, var_log and var_spool_mail. These two values separated by hyphens or statement. So any of the conditions matched, then it will be triggered. And both these blocks are the values of the selection. The selection is the field, these stuffs are values. So both search identifiers should be matched in order to fulfill this specific condition, in order for the rule to get triggered. So that's what. As we have mentioned, the value modifier, it is worth nothing that they appended after the field name with pipe character. And there are two types of value modifiers. So they are trying to say about this one. The parameter, the string that is mentioned after the pipe character. So there are two modifiers. So they are calling it as a modifier. And the modifier types are transformation and type modifier. If you see the transformation modifier, these change the values provided into different values and can modify the logical operators between values. And look at this one, the definition. Here they have mentioned contains. What contains mean? The value would be matched anywhere in the field. So if it matched anywhere in that log field, then it should be triggered. Then if it is all, sometimes instead of contains, you might witness all. If it is all, then this changes the OR operation of lists to the AND operation. So here the entire list concept is changing. If you are mentioning all here instead of contains, because if it is all, then it has to match both the values of this command line, right? So that's what. And base 64, this looks for the values of base 64 strings and starts with, ends with or other true transformation modifiers. And ends with is nothing but a specific string that ends with. When the specific string matches this, the end of the specific string matches, then it will be triggered. Similarly, the start with. Well, moving to the type modifiers. These change the type modifier values or sometimes even the value itself. Currently, the only usable type modifier is RE, which means regular expression. And it can be, the regular expression can be used for specific Elasticsearch SIEM alone. If you are writing Sigma rule to convert into Elasticsearch query, then you can use this RE, regular expression. Well, moving to the next one, conditional identifier. I think conditional expression. For condition, this is based on the names set for your detection, such as selection and filter, and will determine the specification of rule based on the selected expressions. And you can see the conditional expressions given here, logical and or. So it can be used, the and or can be used. One of all, I think 1/all of search identifier, 1/all of them, all of them. One or all of them, one or all of search identifier. That's what I think they are mentioning here. And not operation. Well, moving to the next one. An example of these conditional values can be seen in the exact below the remote copy file rule. So they are referring another Sigma rule here, and here is the specific code block, and they got two lists here, and also they got all the two lists under the value of detection map, and you can see the condition here. So they are mentioning both tools and filter search identifier here, separated by and conditional expression, and both the search identifier should be matched in order to fulfill this, in order to this rule get triggered. And here is the next example. Another example to showcase a combination of conditional expressions can be seen in the extract below. Okay, they gave another code block here, and look at the conditional expression here, and here is the search identifier selection, and they have mentioned a couple of search identifiers, and they have mentioned another field called filter chrome, and under this there are two search identifiers. Under filter edge field there are two more search identifier. Like this, they have mentioned few search identifiers, and they are using the conditional statement at the end. And look at this selection, they are choosing both of these search identifier and not one of filter. So it shouldn't contain any of these search identifier. It should contain only this one. I think that's what they are trying to mention here. Now let's read through this. Where the detection seeks to look values for, where the detection seeks to look for values on the map that starts and ends with various registry values, while filtering out Google Chrome and Microsoft Edge entries that would raise false positive alerts. Yeah, it is filtering both Chrome and Edge search identifier, only takes this specific stuff. All right, so that's what this conditional expression. So it is very powerful. Whatever you write in the search identifier, it can be made meaningful or meaningless based on the conditional expression. So that is the brief explanation for this conditional expression and search identifier. Well, let's try to answer the questions given here. Which status level could lead to false results or be noisy but could also identify interesting events? Well, the status level. When we were reviewing the status section, we have seen there are 5 types of statuses: stable, test, experimental, deprecated, and unsupported. Out of these 5, only the specific experimental status matches with our question. The rule is very generic and being tested. It could lead to false result, sometimes noisy, identify interesting events. So the experimental should be the answer. Let's try to give this. Yes, it is. And the next one, the rule detection comprises 2 main elements. One is conditional expression and another one is the search identifier. So these are the search identifier where we are going to mention the patterns that fetched from the log, and the conditional expression we are going to mention later on. And search identifier would be the answer. And moving to the next one, what 2 data structures are used for search identifiers? So when you are mentioning the search identifier, as I mentioned before, we will be using list as well as map. So somewhere I have seen it. So yeah, here it is. We are using both lists and maps. So that's what they are asking. So let's give this as an answer, and that's the right answer. Well, moving to the next one. So we are going to write a rule. Actually, they gave the rule part by part. They are going to combine that rule and we are going to convert that rule into a specific SIEM signature format. Well, that's what our objective, our intention for this specific task. After going through the basic syntax of Sigma rules, it is crucial to understand how to write them based on threat investigation. As a SOC analyst, you must go through the thought process of developing your detection and writing the rules appropriate for your environment. We shall use the scenario below to go through this process. They gave the ELK instance and we can access this URL in order to get the page, the login page of the Elasticsearch. And you can see the credential given here. So let me enter the username and password. I'm appending 1234. That's the difference between username and password. It is logging in. So Let's see the dashboard. It is loading the Elastic, the ELK instance, and look at this. Now we are getting the empty page, and you can see the last 30 days logs are given here. So I'm simply modifying it to 1 year. So we are going to see the logs that is recorded in last 1 year, and you can see there are more than 1 lakh hits. Well, now we got the SIEM solution ready. We got bunch of logs here, and we are going to write a specific rule, a sigma rule, and we are going to convert it using the conversion techniques that we are going to see now. And once it is converted to the ELK query, search query, we can use this search query here in the search bar to find a specific log. For that we are writing the rule. Well, that's what we are going to see. And look at the scenario here. And actually the scenario is fetched from one of the DFIR report tweets, and you can see the scenario here. So I'll try to explain with the image now. Look at this. It is a scenario for AnyDesk installation. AnyDesk is the remote in management tool which can be used by the threat actors for the nefarious purposes. So we are going to detect the AnyDesk installation on Windows operating system, and for that only we are going to write the rule. And let's see the step-by-step crucial stuffs that happens when AnyDesk is installed on Windows system. Look at this one. Actually, it is creating a folder called AnyDesk under the program data of C folder, and look at this one. It is actually a PowerShell command. They created a separate variables to denote each and every parameter here. New object system net web client. So this is to give the web request, and in the next variable they have mentioned the URL. So from this URL they are trying to download the AnyDesk executable, and in the next one you can see the downloaded executable files stored in the program data folder, and in the next one it is downloading the file from the URL. And look at the next command here. It is using command prompt to execute that AnyDesk file, and it is installing it on the separate folder called AnyDesk under the program data. And in the next step it is setting password for the AnyDesk application, and you can see the subsequent activities here. It is using net user command to create an administrator with a password, and it is adding that specific new user into the group of administrators, the local group. And also it is doing some modifications on the registry keys, and it is making that new user part of the special accounts group. So that is another activity happening here. And so these are the crucial stuffs that we can see from this AnyDesk installation steps. Actually this is gathered from one of the DFIR tweets that I mentioned, as I mentioned before. Now we have seen the list of activities happening when the AnyDesk is installed on Windows endpoint. Now when you are seeing this kind of activities, suspicious activity description, you should be knowing, you should know what are the values are important, what values to be taken to write the sigma rule, what values would be effective, if you want to detect similar activities. So that is a very important point, very important thing that you need to make sure before writing the sigma rule. And you can see the certain things they have given here. First of all, you have to make sure the source URL, and you can see the source URL mentioned here, from which URL the file is getting, from which URL the file is being downloaded. That one is very important. And the next one is the destination file. Once the file is downloaded, you would be storing that file somewhere, right? In some name. So that is very important. And it is using the command prompt. Then they have mentioned that one is very important. And you can see the parameters, -- install, -- start with win, silent. So these are the additional parameters that are used to run this AnyDesk at the back end silently. So these three strings are very important. Since the AnyDesk is being installed by the threat actor, it is actually executed at the background silently. So we are using these strings to detect such activities. And along with the above mentioned values, you can also take the new administrator name, the new administrator that is being created, and also the administrator added into a special accounts group, right, by tweaking the registry. So you can also take that into consideration while before writing the rule. And now we got few parameters. We are going to use these parameters in our sigma rule, and at the end of this sigma rule we'll be able to convert that sigma rule into ELK query, and we can use that ELK query into this specific SIEM to detect that specific event. Well, now you can see the top three: title, Anydesk installation; status, it's an experimental rule; description about the rule. And the next one, log source. It is vital. You have to mention the proper log source here. And you can see the log source, they have mentioned process creation. Since it is using the command prompt here, the process will be created, right? So that's why they have mentioned process creation here, and the product is Windows. Well, it looks good. And the next one, step 4, detection description. We've already taken the important strings from the scenario given, and we are going to use those important strings in this selection search identifier, right? So let's see how they have used it. Under the detection, they have created selection as a search identifier. I think selection. Under the selection, they have mentioned the search identifier as command line and current directory, and they are piped it into contains and all. And you can see it has to contain both install and this one, and along with this specific directory. The current directory should be program data and anydesk.exe. So whenever the Anydesk is installed from this location along with these strings, then it will be triggering that, because we have mentioned in the conditional statement as selection. So that is what this rule does. So let's gather all the parts of this rule. I think there is one more part, the rule metadata. This part is very important for a rule, but the metadata, it is optional one. But let's see what we have in the metadata. It has the false positive. The Anydesk can be installed by legitimate user. So that's the false positive. And level is high. So it's a high severity rule. And you can see the reference. So this is the link of the DFIR tweet. So that's what given, and the tag. So look at the equivalent MyTray TTP. So that is mentioned here. So now we got the complete rule. So they separated the rule part by part, and they gave definition for each and every part. So let's merge all these 4 parts, and let's try to convert this rule to the specific SIEM search query. Perfect. Now I think we got that rule that we need. So this is the sigma rule that we have combined from this definition. Now we need to convert this specific sigma rule into that SIEM signature query. For that, there are 2 options. You can use sigmac or you can use uncoder.io. Uncoder.io is a website. It's a straightforward. You can see this here in this GIF file. So here in this left side bar, we are going to paste the sigma rule that we wrote, and in the right side, when you click the translate after choosing that SIEM of your wish, this will be giving you that appropriate SIEM query, the equivalent of this sigma rule. So that is the uncoder.io is all about. And if you are using sigmac, then it's an offline tool. You can install this. It is based on Python, and you can use it locally on your machine. So it's a command line tool. You can see the usage here. I don't want to get into this deeply to avoid the unnecessary confusion, but you can install this one and you can try. So here is the link. So I'll be trying to copy all the links that is mentioned here in the video description so that you can refer it. All right, look at this one. So once they have installed, they are making sure by calling the help menu, and these are the separate parameters to be used while calling the SIGMAC. And look at this here, -t to mention the SIEM solution. So here it is Elasticsearch. That's what they have mentioned after -t, and -c to mention the location of the Sigma rule that you wrote, and backend option you need to mention that. And once you mentioned and executed this, and it gave the search query of the specific SIEM. And so this is the command for the SIGMAC to Elasticsearch conversion. If you are converting to SIGMAC to Splunk, then you should be using this one. And here is the outcome for that. Well, I'm not going to use this SIGMAC for the role conversion. Instead, I'm going to use the uncoder.io. So let me get into that site. I've already copied that Sigma rule. It is in my clipboard. So I have pasted it here. I'm choosing Elastic Query here. You can choose either of this. I'm simply clicking the down arrow. You can see the list of available SIEMs. So it is covering almost all the SIEMs. It also contains the Microsoft Defender for Endpoint. Well, now I am choosing the Elastic Query and clicking translate. It gives the equivalent Elasticsearch query. Well, it is not safe to use as it is. We got this Elasticsearch query. If we simply copy this Elasticsearch query and paste it in that Elastic instance, we won't be getting the proper outcome. So let me show that. And here it is. So I am pasting this search query and giving update here. Last not 30 days. I need to mention 1 year, I guess. And update. Still it is giving the error because this query is invalid, because it is generated in online by uncoder.io. We need to tweak certain stuffs here, and that's what they gave. So it actually gives the wrong query, because you can see this one. Here is the tip. Be aware that the converted queries may not all work verbatim as converted from the tools. This is due to the processing of regex characters like // and star. And you may be required to adjust the queries, especially around the escape blank space. For example, for this exercise, you have to remove the star characters from the result and only escape colon in the folder path and the directory slashes. We need to remove the asterisk values, but not in all the places, only in certain places. Let's do that. Here is the rule. So I'm just giving the word wrap here. All right. Now I got this one. Let me try to edit this. I'm removing this asterisk value, and the asterisk I'm removing, and I'm putting the space again, and looking to correct more. Here I'm removing the star, the asterisk. Well, you can see the / is added to escape this hyphen, I guess. Here is also the same story. I'm removing this asterisk, and yeah, looks fine. I think it should work. Let's see. I think it throws some error. It is not giving the correct outcome. Let me see this. I think it is still wrong. Let me correct it. I have found what was the issue. I need to remove all these backward slashes except the backward slashes that is given to escape the existing backward slashes in the Windows path. Now I removed the backward slashes, the unwanted backward slashes, and here I am copying this query now and putting it in the search bar and enter. Now you can see earlier we were seeing multiple hits. Now it reduced to one hit. And look at this one. So here is the outcome that we need. I am simply clicking this expand button and copying it to the clipboard, and I can paste it here, and we got the detail about the log that we are looking for. The log of AnyDesk installation that follows the pattern of this one. Well, let's try to answer for the questions. What command line tool is used to convert Sigma rules? And the the command line tool is nothing but Sigmac. We have seen here in the conversion topic, we are using Sigmac. It's a command line tool. Well, I haven't used it, but that is the answer. It's a command line tool. You can try this. At what time was the AnyDesk installation event created? So in order to answer this question, we need to check the time here. So this is the time. So let's paste it here. It has to be in this format. Month, date, year, at the hours, minutes and seconds. So I'm removing the unwanted parts, and that's the right answer. What version of AnyDesk was installed? And here we need to look the version of AnyDesk. And I'm going to the hint here. Look at the available version field. Now we got the log here. So this is the log that we have gained from the Elasticsearch query that we have created from the Sigma. Now by going through this one, we are going to find the version of the AnyDesk that is installed. So here is the number of characters. So let me find that version. I need to look for the version of the AnyDesk. Look at this one. WinLog on even data file version 7.0.10. I think this could be the answer. Process PE file version. And I think this is the version. And look at this, the file version. AnyDesk file version. It is nothing but 7.0.10. And fortunately, that's the right answer. Well, moving to the next part. SecOps decisions. It's a theory. So it's a theoretical part. So they gave an alarm. So when you are using this one, this Sigma rule conversion process, either it can be uncoder.io or Sigmac, you need to keep certain things in your mind. Both the results will be differ. So when you are using Sigmac, you will be getting a result. When you are using uncoder.io, you will be getting a different result. This is up to you to make a decision to choose any one of the outcomes. Well, that's what they're trying to say here. Let us consider converting the CH mode. Okay, they gave an example here. So they gave couple of both the conversion process, conversion using Sigmac and conversion using uncoder. When you are using these two tools to convert a same Sigma rule, it is actually giving two different queries. Now look at this one. It actually differs. Now they are asking you to choose between these based on your requirement, and that's what their advice. So with this, we are completing the theory part of Sigma, and in the next task we are going to learn the practical stuff, which means we are going to write couple of Sigma rules based on the real-time scenarios, but that is for the part 2.